Hello, this is Sheridan, and this is not Analog 101. This is just me digging around in falstad with current projects, and just want to show them to you. So, I can't believe I made it this far in electronics, not knowing this, but I finally learned what a virtual ground. Well, I knew what a virtual ground was, but I didn't know like how it was made. I learned how to make a virtual ground. So. We'll start with a blank circuit. I'll show you how to make virtual ground, and then we're going to build an amplifier, because this is kind of how amplifiers work with single supplies, since they often need split supplies. So we'll start with a blank circuit. So all you do, let's make our rails here. So we've got our, let's say you've got a 2-terminal voltage source. Voltage source 2-terminal. That's the other way. No. This way. So you can't make positive and negative voltage out of this, but you can still split it. And the way you do that was with a voltage divider. Just gonna make things even here. So the cool thing. So now we have our center line reference, which we will make our ground. Problem is, if you try to just run your ground directly to this point, you're going to have problems because your circuitry is going to affect just how much voltage this has, and your ground is going to be all over the place. So you have to have something that's going to keep it steady or isolate this point. I'll get it to show voltage. So we are going to give this 20 volts, since a lot of our adapters run that. Actually, 24. Because why the hell not? So now we have positive and negative 12. Let's run ourselves a little less current. So I'm actually working on this on my bench at work as sort of a break time project. So to make a virtual ground, all we have to do is amplify this point and give it a current source. Now there's several ways to do that. I think the easiest way is with an op-amp. You can obviously do it with a Class B amplifier. There's some other ways. So I'm going to show it to you with an op-amp first. So check this out. Building blocks. So we simply make a buffer. It's stupid simple. Now we have we have 12 volts, and that point is not going to move no matter what any other voltage is in the circuit, because an op-amp isn't going to feed back voltage into this area over here. It's just going to keep it all the effects of an op-amp are isolated on this side. So we don't have to. So if you're like running an amplifier, you have to take into account that all of your current is going to have to run through this point at some point. So your op-amp either has to be able to handle that amount of current, or the way you can get around that is by adding a resistor and then putting your DC filter caps, just like you would. Oh yeah, okay, so yeah, a falstad is going to have problems unless you add a little bit of resistance to your voltage source. So we're going to make this 1 nano-ohm. Reset. Okay. Run. So now we've got our virtual ground, and the caps will take the brunt of most of the current. And obviously you can run very, very small currents to help correct our ground. That's what the purpose of the op-amp is to make sure we can run some small currents to correct the ground and make sure it's always equal or at least close to our reference point. The smaller this resistor is, the better time it will have of correcting ground, our virtual ground. So now let's make a bridge amplifier with our new split supply. I just realized this is not centered. It's not centered, sorry. OCD is going to take over for a little bit. There. So, what kind of? Let's build a bridge amplifier. In fact, let's build the amplifier that I've been talking about. So the cool thing about this amplifier is that it requires no idle current except for the quiescent current in op amps. So we're going to start with our basic op amp. Then we add positive and negative resistors. What is that music? Yeah. I love Odessa. So what we're going to do is, instead of taking our feedback loop from the output of the op amp, we simply take it from the output of the transistors. So that way, any biasing that needs to happen for these transistors happens in the feedback of the op amp, and it doesn't have to have a bias network, which is really, really convenient. So we just leave ourselves a node there, then we can put that there, make ourselves an inverting amplifier. Okay, that was weird. There. Let's get this centered. Bam. So let's give this an input. And you'll see if we speed up our scope, okay, there's something not working right. Oh, I know what's not working right. You know what's not working right? That. Also, we have to adjust our op amp's swing. And we do not tie this to actual ground. We tie this to our virtual ground because everything. I'm gonna make this virtual ground right here. And this is gonna be our virtual ground line. Now wait for it. That's not supposed to be it. Okay, this is like 10 ohms or something. Let's make this 2200. That is the glitch mob you're hearing right now. Okay, I know this works. I don't know why it's not working now. I'm just getting like straight DC. I don't understand. I'm gonna pause the recording. I don't know how to pause the recording, sorry. I'll just edit this part of the video out while I figure this out. Ah, wait. I know what's wrong. Okay, so since we're running a virtual ground, we have to isolate our input from the amplifier because the input is going to give us actual negative voltages. It's not going to give us virtual negatives. So, yes, the virtual positive, virtual negative. So, what we have to do is we have to put a capacitor in to isolate it, and it will allow our voltage swing to be biased. And usually you want to make these fairly tiny. There we go. Now it's correcting itself. Or it's trying to. Maybe I have it overdriven. Yeah, I know I have it overdriven. 1 volt. There we go. We're still a little bit overdriven, but we have now created an amplifier that works. So we can obviously just put a resistor here, and it looks just like a regular amplified signal. And the speaker's typically 8 or 16 ohms. Yeah, there we go. That's a little smoother now, isn't it? Let's look at our peak negative. Trying to figure out why we're clipping there. There, now we've gotten rid of our clipping. I think it just took some time for our bias to adjust. And that took less than half a second. Cool. So now, at this point, we can build our bridge amplifier. Oh no, we're still clipping. Why are we still clipping? I don't understand. So let me slow down the simulation for you, and you'll see this current is not moving whatsoever down here whenever this is moving, so it's perfectly efficient. Let's see. Okay, that's why we're clipping, because this cannot supply enough current to correct the ground. So all we need to do is lower this resistance, and there we go. Now I think we can stop clipping. Yes. So let's view this in the scope. And you can see it does fluctuate a little bit. And the way you minimize the fluctuations is by lowering this resistor. Now obviously you can't lower it to 0, because that might be too much current for your op amp to handle, so you just increase your capacitors. As you can see, most of the current is actually going to the capacitors and not through the resistor. This is just giving us milliamps, maybe 100 at a time. But it's only varying a little bit. And as long as, you know, this doesn't show up in our audio, it doesn't really matter. So let's do that. Whoa. What is it doing now? Oh, it's correcting. Wait a minute. Okay. What's going on? I don't understand what's going on. I think I may have went the wrong way. Yeah, I'm pretty sure I went the wrong way with that adjustment. I don't. Why is it doing this? You know there ain't no rest for the wicked. Money don't grow on trees. We got bills to pay, we got mouths to feed. There ain't nothing in this world for free. I know we can't slow down, we can't hold back, though you know we wish we could. I know there ain't no rest for the wicked until we close our eyes for good. I think we got somewhere. Yeah, it probably just didn't... Okay, so it probably just didn't give it time to adjust to the new... Yeah, this capacitor needed time to adjust to our new bias. Or our new gain loop. So... So yeah, there's a cutoff frequency with this capacitor and there's a resistor. It will start attenuating signals that are below a certain frequency, and I think I set our yeah, this goes from 100 to 1K. Yeah, we could totally up the current with this. What current are we running now? Oh yeah. Oh yeah, that's beautiful. Beautiful. Our graphs still don't work. Are we? I'm still trying to understand why we're clipping. Waiting for this voltage. To start matching this voltage. Or the inverse of it. But it doesn't seem to. I know this part works in split supply, it's just this isolation that I'm worried about. You know, I'm gonna try giving it a transformer. See if we can just isolate it with a transformer instead of a... In fact, that's what I would want to do in real life, since this is an untested circuit. I don't know what it's gonna do. So what we can do with a transformer is connect one end to our virtual ground and not have a need to isolate it with this capacitor. So all we do is put one end there, one end over here, ground over here. Whoa. What? 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 Okay. This is weird. Believe me, I'm trying to figure out what's going on. These voltages are not moving, so it's not waiting for a correction.
A little ways from you.
This is a real head scratcher.
Hey, this night is young, let's have some fun. Turn it up. Hey, let's break it down to some funky town. What up? Moving to the sound. Get yourself out on the floor. If you don't know now, you know. Gonna dance all night, let's go. You and I put on a show. Get yourself out on the floor. If you don't know now, you know. Gonna dance all night, let's go. You and I put on a show.
How is this negative 50? That doesn't even make any sense. Kill it. How am I running kiloamps? Okay, we got something wrong. This is glitching out, I think.
Don't stop, let the music play. Get yourself out on the floor. If you don't know now, you know. Gonna dance all night, let's go. You and I put on a show. Get yourself out
Is there a voltage drop again?
Get yourself out on the floor. If you don't know now, you know. Gonna dance all night, let's go. You and I putting on a show. Get yourself out on the floor. If you don't know now, you know.
Let's see what happens if we do this.
Let's go. You and I putting on a show. Get yourself out on the floor. If you don't know now, you know. Gonna dance all night, let's go. You and I putting on a show.
I think we got somewhere.
On the floor. If you don't know now, you know.
So all I did here is I moved the reference of 0. I moved I moved a reference. I still have no idea what's going on. So this, okay, forget this transformer. We're just gonna capacitor isolate it. It also might be the fact that we're dealing with an inverting amplifier and not an actual amplifier. Let's actually make this 500 nano. Okay. Let's go back to what was working.
The walls are closing in around us. We hold our silence like a gun.
So I think it needs to wait for a correction since we are dealing with a bias filter cap. Which means we need to speed up time until it corrects itself, which it looks... like maybe it's doing? I'm just gonna try adding a biased wave.
Footsteps will fade away the memories. Unload the words and breathe again. Our eyes are focused on an unexplored horizon.
Oh, I know what's going on. I know what's going on.
They can't take this away. It's far from over. We can't stay in a place we don't belong. For one more day, I'm not afraid to fall.
Okay. Now we're fixed. Now we're fixed. Okay.
Won't let you look back.
So. Now, let's see what happens if we take this off. Put it here.
Holding it together, birds of a feather, nothing but liars and crooked wings. I have the answer, spreading the cancer. You are the face inside
So, as you can see, these voltages match very closely. Because they should be equal. Sometimes they're not, but and it also could be. Okay, we're still clipping on the negative. We're still clipping on the negative part of our wave here. So, I'm trying to figure out what's causing that.
I'm a believer, nothing could be worse. All these imaginary friends, hiding betrayal, driving the nail, hoping to find a savior.
I wonder if it's this thing.
Leave me to die here, help me survive here alone. Surrender, surrender. Put me to sleep,
We are clipping a little bit on our top part of our wave as well. Okay, I'm satisfied with that, unless. Okay, I'm still trying to identify the discrepancy we've got going on here. So, okay, well, I'm gonna try one more thing. I'm gonna try putting emitter resistors on. I don't usually use them in simulations because I've never, like, I've never had any problems. Emitter resistors are mostly for actual protection of the circuit in real life, but I'm just gonna use them here. It's like we are lagging really bad. I'm really baffled by why we're clipping so much. See what happens when we get to a high frequency. Still clipping. I don't. And it's only on the negative side. It looks like I don't know what I did, but it stopped clipping. Yeah, I tweaked the gain. That makes me dizzy. Alright. That's kind of pathetic. Okay, never mind. I thought it only got to 3 volts. I was like, no, I need more power. Okay, so we should have a swing of 24, well, almost 24 volts, but so far we're only getting 10? Oh. Duh. Oh my gosh, I can't believe this. I cannot believe this. We have a 24 volt supply. God damn. Okay. Wow. Oh. I have no words. I have no words. I'm sorry. You know, sometimes making circuits in falstad is actually harder than real life. Anyways, on with the fucking show. Alright, let's bridge amplify this bitch. How do I do that? NPN transistor. PNP transistor. Yeah, we're pushing our limits there. We're clipping evenly though, and we have a swing of almost 12 volts. Excellent. So that means we can get rid of this trash. math in my head. There we go. Yes. Uneven wave. Okay. Okay. Shh. Don't breathe. You'll scare it. So we're just going to leave it at that gain. Now for bridge amplification, we need...
I'm in love with an angel, heaven forbid. Made me a believer with the touch of her skin. I go to hell and back with you, stay lost in what we found. Worlds apart, we were the same until we hit the ground. Maybe I'm crazy, maybe I'm weak, maybe I'm blinded by what I see. You wanted a soldier, but it wasn't me, 'cause I can never set you free. So fly on your own. It's time I let you go.
Wait a minute. Wrong ground. That's the wrong ground. Virtual negative.
I'm in love with an angel who's afraid of the light. Her halo is broken, but there's fight in her eyes. Walls are built to keep us safe until they're crashing down. Worlds apart, we were the same until you hit the ground. Maybe I'm crazy, maybe I'm weak, maybe I'm blinded by what I see. You wanted a soldier, but it wasn't me, 'cause I can never set you free. So fly on your own. It's time I let you go.
Maybe. Maybe.
Walls are built to keep us safe until the crashing down.
Oh, we're inverting. Duh.
Worlds apart, we were the same until you hit the ground.
Yeah, we're inverting. Whoops. Okay. So I gotta figure. Virtual ground. That's a virtual ground. Yes. Yes. Okay. Yes! Now we have full voltage swing. The maximum that this can possibly provide. So there you have it. This is augment feedback virtual grounded bridge amplifier circuit. What a pain in the ass. It's time to go to bed. Alright.